Hey guys, this is the third episode in this series of finding the derivatives of trig functions. And for the first two episodes, check links down below to be on the same page with me. And we will be focusing on more complicated forms. Say you have trig expression, two terms, or it could be more than two terms raised to a power, to the fourth power, or any power. Or another type, what if you are given a trig function, let's say cosine not of x, but of x cubed, or also it could be any power, minus or plus something, another expression. And finally, I will walk you through something like square root, or also it could be any root of inside function, which appears to be sine, cosine, or any trig functions. So again, for more basic types, for introduction, watch out the first two episodes. So how to take the derivatives of all of these forms that you might encounter. So let's get into this one by one. Alright, the first type we'll be focusing on. Say you have 2 plus sine of 3x, all this entire expression raised to the fourth power. And you might be wondering how to start off, which rule should I apply first? You have a power rule, you have the derivative of sine, you have the chain rule. Might be a little bit confusing at this point. But look at this expression and try to imagine this big picture. What are you given? You are given some expression raised to a power. From that point of view, from that big picture, you are given x expression. Whatever you have inside, it could be any expression. It could be sine, ln, or exponential function, or even their combinations or concoction. And it's that giveaway that your outside function is a power. So first thing to apply is a power rule, since you are given something to a power. So needless to say, you have to apply the chain rule after. So y prime, the derivative of this function equals most outside, it's a power. So by the power rule, you want to bring this power out front as the coefficient. You want to keep your expression, whatever you are given, first, and you want to reduce your power by 1. So 4 minus 1, that becomes 3, that's your new power. And you are going to rewrite your expression as this, unused, unchanged. So 2 plus sine of 3x goes inside the parentheses. So sine 3x. Now, we are not done yet. By the chain rule, you have to take care of the derivative of inside function. Look at this, what you have inside. First of all, the derivative of 2 is going to be just 0, since 2 is a constant. Moving to the next term, you have sine of 3x. And first of all, you need to take the derivative of this sine. So recall that the derivative of sine x is just cosine. So go ahead and multiply this function by cosine of 3x. Cosine 3x. Also, at this point, you want to keep the original argument. 3x goes as an argument for cosine. And again, we are not done yet, since your sine, original sine, is made of 3x. So you have another function of function. So another function, namely 3x inside of sine. So you have to take the derivative of 3x. And the derivative of 3x is going to be just 3. So this thing gets multiplied by 3. And I'm going to draw the parentheses in order to do not confuse it with this argument of cosine. And basically, we're done. It's supposed to be in more neat and compact form. So in order to get this, we want to combine like terms. 4 times 3, that would leave you with 12. So you want to rewrite your expression 2 plus sine of 3x cubed as this. and this term gets multiplied by cosine of 3x. And this is your derivative for that function. Alright, moving on. Here's one more. What if you have something like cosine x cubed minus 5? Notice it's not cosine cubed of x, so do not confuse this with cosine cubed of x, which is completely different. What you are given means that your argument x raised to the third power. You could simply go ahead and rewrite it as cosine of x cubed with the parenthesis around x cubed, meaning that your argument x raised to the third power and minus 5. That being said, this expression means completely different. All that means is your function cosine x raised to the third power, meaning that cosine x multiplied by itself 3 times by the definition of the power. In this case, in the first case, means x multiplied by itself 3 times. Now, if you are given something like this, check out my first 2 episodes where I did break down this case. In case if you are wondering why I warn you about these 2 different cases, my answer is depends on what are you given. You have to apply different rules of differentiation. Actually, that's my point. Alright, get back to your original function. So cosine x cubed minus 5. Now, first of all, you have 2 functions actually. You have 2 terms being subtracted. So the entire derivative is going to be the derivative of the first piece, of the first chunk, and the derivative of negative 5. Since the derivative of negative 5 is going to be just 0, so negative 5 goes away, we could simply ignore this term. So this task comes down to taking the derivative of just cosine of x cubed. Y prime will get. So needless to say, you have to use the chain rule. First of all, you need to spot what is your outside function and what is your inside function. So look at this, cosine of x cubed. So the outside function is going to be cosine, since you have something inside. You have cosine, the foremost outside function, and inside you have x cubed. So first of all, you have to find the derivative of cosine, and remember that the derivative of cosine is going to be negative sine. So go ahead and write it. So negative sine, and you want to keep this argument x cubed, since that's the argument of your original function. You could also draw parentheses around if it helps you. We are not done yet. So by the chain rule, you have to take care of the derivative of x cubed, and x cubed is just power of x. So by the power rule, you want to bring this 3 out front as the coefficient, and you want to reduce your power by 1. You want to knock it down by 1. So 3 minus 1, that would leave you with second power. So that's your new power. And check to see if you have more functions nested inside. So in this point, in this case, no. And basically, we're done. It's supposed to be more clean and compact. Go ahead and just simplify it. After simplifying, we will get, so you want to pull this 3 in front as the coefficient, and typically this also algebraic term x squared goes in front, and you still have this sign of x cubed. No need basically to draw the parentheses, since by the default this power 3 belongs to x to the variable, so it's next to x, it's adjacent to x, so that's your final derivative. Suppose you come across something like this: square root of sine of x squared minus 2x. Looks a little bit scary. As a good rule of thumb, the first thing you will do is whatever you need to use to handle outermost form of your expression, of your function. And look at this: if you are given that form, it's a dead giveaway that you have a function of a function, and hence have to use the chain rule. And look at this: you are given a square root of something. Whatever you are given inside, your outermost is a square root. And it's that giveaway that your outside, the outermost function form, is a square root. So you can basically break it down. So this you have square root. So this is your first outside. Next, you have something like sine inside of your square root. Again, it's a dead giveaway that sine's gonna be second function, second form that you wanna take the derivative of. And finally, you have this expression inside, x squared minus 2x. So you have to take care also of the derivative of this form. All right, let's get started. So y prime becomes, so again, the derivative of square root. So the derivative of square root is gonna be 1 over 2 square root of this. So that's kind of a separate rule, the way I do remember. If you don't remember this rule, that the derivative of square root is gonna be 1 over 2 square root of something, you could simply go ahead and rewrite square root as a half power, and by a power rule you would come up with something like this. Anyway, sine of x squared minus 2x goes inside of your square root form. So sine of this argument, so x squared minus 2x. And we're not done yet, obviously. We have to take the derivative of sine. This is your second derivative. So actually we're going to have these kind of small derivatives linked to each other. So the derivative of sine is cosine. So that term gets multiplied by cosine of x squared minus 2x. So this is your argument, which is inside of your original sine. So x squared minus 2x goes as an argument for cosine. And again, we are not done yet. So we need to take the derivative of x squared minus 2x, and this is just algebraic expression. And I believe it's going to be just a piece of cake. So the derivative of x squared minus 2x by the power rule and by the constant multiple rule, if you will, it's going to be just 2x minus 2. This term gets multiplied by 2x minus 2. And I'm going to draw the parentheses over here in order to do not mundle these 2x minus 2 and the argument, which is basically very looking similar, the argument of cosine. So it's considered simpler to rearrange it and combine like terms if possible. First of all, since you have 2x minus 2, pull out this common factor 2 from both terms, and you are left with something like 2 times x minus 1. And since, look at this, you are given 1 over times this entire expression, technically 2 times x minus 1 goes on top. And these 2 and that 2, they're going to cancel each other out. There is nothing else that you can do. All you need to do is just place x minus 1 on top of this fraction. So you basically, the derivative is going to be a fraction. So since x minus 1 is an algebraic term, and typically we put it before the trig function. So cosine x squared minus 2x remains on top, and your bottom just becomes a root of sine of x squared minus 2x. So that remains on bottom. Again, 2 goes away, since these 2 on bottom cancels out with these 2 on top. So, and that's your derivative after this simplified. Right, I hope it has been helpful to you. Huge thanks for watching and training your brain. I know everyone hates math, but if you like my video, please hit dislike, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't. Also, make sure to turn on the notification bell so you will not miss out my new uploads.